In this next little group, we want to introduce some basic functions. We'll use these more in the next section, in section 2.7, and we'll talk about graphing a little bit more. And you should have already seen these, though, from college algebra. And we'll cover it again, like I said, in the next section, in section 2.7. So what we're looking at here is we have a line. It says f of x equals x, which is just the line y equals x. It's a line that goes through the origin here at 0, 0 and has a slope of 1, 1, which means it goes up 1 over 1, which is why it goes through 1, 1, and then 2, 2. It goes up 1 over 1 because its slope is 1. Rise over run is 1 over 1. Its domain, reading it from left to right, is, let's see, you trace from left to right, the graph goes forever in both directions, so its domain is negative infinity to infinity. And its range is going from bottom to top, goes up and down forever, so its range is also negative infinity to infinity. So this is one graph we're going to see over and over again in this chapter. Another graph is, I know that says f of x equals x squared. That's also y equals x squared is the same thing. And just as a reminder, that's because f of x and y mean the same thing, so they can be replaced by one another. This graph goes through 0, 0, 1, 1, and negative 1, 1, and it's got this U shape. We call this U shape a parabola. And its domain, if you're looking at your graph, from left to right continues in both directions forever. So its domain is negative infinity to infinity. And its range, be careful, is a little bit more complicated. Starting down at the bottom, there's no graph. It doesn't start until here at 0, but does continue on forever after that. So its range is 0 to infinity. And we do have a graph at 0, so the range does start at 0 with a bracket because there's a graph there. The next one, the x cubed graph, is going to be y equals, it's going to be y equals x cubed. So it'll go through 0, 0, 1, 1, 2 would come out as 8. 2, 8, and then you'd continue on forever in that direction. Negative 1 would give you negative 1. Negative 2 would give you down at negative 8 and would continue on forever. Its domain, reading it from left to right, would be that it goes left and right. Let's see, forever in both directions. So its domain is negative infinity to infinity. And let's see about its range. Going from the bottom and working our way up, it does continue down and up forever, so the range would be negative infinity to infinity. And this one I tend to call the snake shape, because it kind of looks like a snake coiling upward, so we'll say the snake going up. Okay, well, if the square root is a U shape pointed upward, a square root, which is the opposite, should be kind of a U shape on its side. The problem is if you take the full U shape on its side, what would be the problem? Is that it wouldn't pass the vertical line test, which would mean it would not be a function. So when we look at the square root function, it's a function means we're only actually going to look at half of the graph. We only look at the half of the parabola on its side, which goes through 0, 0, 1, 1, and 4, square root of 4 is 2, so it goes through 4, 2. Notice, tracing along from left to right to get its domain, notice our graph doesn't start until here at 0, and then it continues on forever. So its domain is from 0 to infinity. It does have a graph at 0, so we will include that, so there will be a bracket there at 0. Its range is pretty similar. starting at the bottom of the graph and working its way up. It doesn't start until here at 0 and then does continue upward forever. So it'd be 0 to infinity again. Notice again that there is a graph at 0, so we can include that, and we'll use a bracket at 0. And so this is the reverse of the parabola. It's a square root graph, so it's going to be half of the parabola on its side so that it remains a function. Last one. The last one here, the cube root function, is going to be the same as the cube function, just on its side. So I always call this one the snake on its side. Just like the square root graph is the squared graph on its side, the cube root graph is the cubed graph on its side. And it still goes through the same points, which is 0, 0, 1, 1, negative 1, negative 1, but it goes through negative 8, negative 2, and positive 8, negative 2. But it does continue on forever. Its domain, just to look at that first, left or right does go on forever in both directions, so its domain is negative infinity to positive infinity. And let's see, its range, starting from down up, does continue in both directions forever, so its range would be negative infinity to positive infinity. Actually, I was wrong. There is one more graph. We just did y equals the cube root of x. The next graph is y equals the absolute value of x, which is now going to be looking at what is a V shape. And the idea with the V shape is it's kind of like a take on the line y equals x, which is the line going through the origin with slope 1, and all that does is does what the absolute value does, which is, remember, the absolute value takes whatever part is negative of a graph and flips it up. So it would take the negative part, which is this piece here, and it would flip it up top to make it positive, which is why you end up with that V shape with the absolute value graph. It does go through the origin at 0, 0, it does go through 1, 1, and it does go through negative 1, positive 1, and it always has that V shape. The domain of this guy, looking from left to right, goes from left to right forever. So the domain is negative infinity to positive infinity. And its range, working its way from down up, doesn't start here until 0, and then will continue on forever. So its range is from 0 to infinity. There is a graph at 0, so we'll have to use a bracket at 0 to include 0 as part of our graph. Now, to look at the full parabola on its side, instead of squaring x, you'd actually have to square y. So it'd be x equals y squared. Again, we talked about this a second ago. We don't usually look at this picture, though, because it is not a function, because it doesn't pass the vertical line test. That's why it's not a function. So it does not pass the vertical line test, but it is good to know that the graph does exist, but it's not a function. Its domain for this graph, when you're squaring y instead of x, is that the graph doesn't even start here until 0. So its domain would be 0 to infinity. Again, there is a graph at 0, so you'd use a bracket at 0. Its range, however, would be that the graph does go down forever and up forever, so its range would be negative infinity to positive infinity. Again, like I said, we just don't normally see this one because it is not a function. However, what we would like to look at are what are called piecewise functions. And it's exactly what it sounds like. The first word breaks up into piece, and then you have the word functions. So what does that mean? It means it's actually a group of pieces that are functions. So the whole thing together may or may not